In this first part, let us look at the big picture of the Codex app server architecture. Codex itself is the core engine, almost like a new operating system for software creation, and the app server is its user interface. Instead of you having to think about low-level software, development kit calls, or how each model is wired up, the app server exposes a simple, high-level interface that can switch between different OpenAI models, including the latest frontier models. So you can build agents that do much more than just write code. Behind the scenes, it can spin up customized Docker images for each user or project, so service providers can scale cost-effectively, even on modest hardware, such as a small single-board computer, because most of the heavy computation happens in the cloud. By encapsulating all of the application programming interface complexity, it makes it easy for developers and businesses to plug coding agents into their workflows without becoming experts in those details. And even though the app server is still labeled experimental, it already powers serious tools, such as rich editor extensions built on top of Codex. Now we move into the forked Codex repository on the host machine. On screen, you can see the Git configuration being checked, confirming that there is a remote pointing to your own fork and another remote pointing to the main Codex project, which is the typical setup when you want to contribute changes while staying in sync with upstream development. After confirming that the repository is in the right place, we run the build script that assembles a Docker image containing the Codex app server and all of its dependencies. This step may take a few minutes the first time because Docker needs to download base images and install packages. So be patient and let the progress output complete before moving on. When the build finishes successfully, you have a reusable image that you can start again and again without having to rebuild each time. With the image built, the next clip starts a new Docker container from it. The important idea here is that we map a directory from the host machine into a working directory inside the container, so that any project files we edit stay on the host while the tools run safely inside Docker. We also expose the port that the app-server-proxy will listen on and give the container a friendly name so that it's easy to reference later when you want to copy files or inspect logs. This setup means that no matter what happens inside the container, only the single mapped host directory can be modified, which provides a clear security boundary and makes it easy to clean up simply by stopping or removing the container when you are done experimenting. In a separate terminal on the host, we now take care of authentication. Before this step, you should already have logged into Codex in the standard way, which creates an authentication file in your home directory. Here we simply copy that file into the container, placing it in the location where the Codex tools inside Docker expect to find it. Doing this from outside the container keeps your normal login flow unchanged, while still allowing the app server running in Docker to authenticate to the OpenAI interfaces on your behalf, so that it can make requests just as if it were running directly on your machine. Back inside the container terminal, we now launch the codex-app-server-proxy. This single step starts the app server process and binds a small proxy on the network port that we exposed earlier, listening on all network interfaces inside the container. As it starts up, you will see log messages indicating that the server is initializing, followed by a line confirming that the proxy is listening, which tells you that the app server is ready for external clients to connect. At this point, the container is acting as a dedicated Codex app server instance for your experiments or services. Finally, in another terminal on the host, we run an example client that connects to the app server proxy over the configured port. On screen, you can see it printing status messages as it connects, reports basic information about the server, and starts a new conversation thread. From this point, you can type prompts into the client, such as asking it to describe the current working directory, and the app server will respond using the model you have configured. Even though the actual server work is happening inside the Docker container, this demonstrates the full end-to-end loop. The host machine provides the user interface, the container hosts the Codex app server, and the two talk over the local network through to proxy, giving you a powerful yet isolated environment for building codex-based applications.